In 1955, just weeks before his death, Einstein said something that no physics textbook will ever teach you. He confided in a colleague that everything we think we know about reality is wrong, not partially wrong, not slightly mistaken, but fundamentally and completely wrong. What he discovered would take nearly 70 years to prove. But here's the terrifying part. In October 2022, 3 scientists won the Nobel Prize in Physics for finally confirming what Einstein feared most. And what they discovered didn't just challenge our understanding of physics, it completely demolished everything you think you know about the world around you. The Nobel Committee used extraordinary language. They said these experiments overthrow reality as we know it. But before I reveal exactly what Einstein understood, you need to comprehend why this information was kept buried in technical journals and academic debates for nearly a century, why something this profound was never explained to the general public, and why what you are about to learn will change how you see everything. Let me start with what you were taught in school. You learned that reality is solid. Objects exist, whether you look at them or not. The chair you're sitting on exists, even when you leave the room. Your phone continues to exist when you put it in your pocket. The moon hangs in the sky at night, whether millions of people gaze at it or whether no one looks at all. This seems so obvious that questioning it feels absurd. This is common sense. This is basic logic. And for most of human history, no serious scientist questioned this fundamental assumption. Einstein himself desperately wanted this to be true. He built his entire worldview on this foundation, and he spent the last 3 decades of his life fighting to preserve it. But here's what they never told you in any classroom. Einstein was not some stubborn old physicist who couldn't accept new ideas. That's the official narrative. The story they spread is simple and convenient. They say Einstein was brilliant in his youth when he gave us relativity, but he became rigid and outdated when quantum mechanics emerged. They paint him as someone stuck in classical thinking, while younger physicists moved forward. This story is repeated in textbooks, documentaries, and popular science articles. And this story is almost entirely false. What actually happened is far more disturbing, and it reveals something about reality that most people are not prepared to hear. The real story begins in 1926. Einstein had already revolutionized physics twice. With special relativity and general relativity, he was the most famous scientist in the world, and he was watching a new generation of physicists develop quantum mechanics, a theory that made predictions so accurate they seemed almost magical. But Einstein saw a problem, a deep, fundamental problem that went to the heart of what physics is supposed to do. In December 1926, Einstein wrote a letter to his friend and fellow physicist Max Born. This letter was kept relatively obscure for decades. Most people never heard about it, but what Einstein wrote would define the rest of his scientific life. He said that quantum mechanics is certainly imposing. He acknowledged it was an impressive achievement, but then he added that an inner voice tells him, this is not the real thing. The theory says a lot, but doesn't really bring us any closer to the secret of the old one. And then Einstein wrote the line that would echo through history. He said, he is convinced that God does not play dice. Now, you've probably heard that quote before. It appears in countless books and documentaries about Einstein, but here's what almost no one explains. What did Einstein actually mean? Was he being religious? Was he rejecting science? And was he simply being stubborn? None of these interpretations are correct. Einstein was making a precise philosophical and scientific claim. He was saying that there must be a deeper level of reality beneath quantum mechanics, a level where the universe has definite properties, whether we measure them or not, where electrons have actual positions even when no one is looking, where the moon definitively exists even at midnight, when every human on Earth is asleep. This philosophical position is called realism. the belief that reality exists independently of observation. And Einstein considered this so fundamental to science that abandoning it would be abandoning the entire enterprise of understanding nature. But Niels Bohr, and what became known as the Copenhagen School, had a radically different view. And this is where reality starts to break apart. Bohr and his colleagues claimed something that sounded insane. They said that particles do not have definite properties until they are measured. Before you observe an electron, it's not in any particular place. It doesn't have a specific momentum. It exists in what they called a superposition of all possible states, simultaneously. The electron is everywhere and nowhere. It has every possible momentum, and none. Only when you actually look, only when you measure it, does the electron snap into a specific state. Einstein found this completely absurd, and he expressed his objection in a way that has become legendary. One day, Einstein was walking with physicist Abraham Pace. Suddenly, Einstein stopped, turned to Pace with genuine concern, and asked a question that cuts to the heart of quantum weirdness. He asked whether Pace really believed that the moon exists only when he looks at it. This was not a rhetorical flourish. Einstein was genuinely asking whether the physics community had lost its mind, whether the most successful scientific theory ever developed was actually telling us that reality does not exist unless someone observes it. And here's where the story takes a turn that should have made headlines around the world, Mikes, but somehow never did. Einstein didn't just complain. He didn't just write letters expressing his discomfort. He constructed a precise argument designed to demolish the Copenhagen interpretation once and for all. In 1935, Einstein collaborated with two colleagues, Boris Podolsky and Nathan Rosen. Together, they published a paper in the Physical Review journal. The paper had a provocative title: "Can quantum mechanical description of physical reality be considered complete?" This paper introduced what became known as the EPR paradox, named after the three authors. What Einstein demonstrated was this: according to quantum mechanics, two particles can become entangled. Once entangled, measuring one particle instantly affects the other, no matter how far apart they are. If you measure the position of particle A here on Earth, the position of particle B on the other side of the galaxy becomes definite instantly. Not at the speed of light, instantly. Einstein called this spooky action at a distance. In German, he used the term spukhafte Fernwirkungen, and he used this bizarre prediction to argue that quantum mechanics must be incomplete. There must be hidden variables, deeper properties that we simply have not discovered yet, properties that determine the outcomes in advance, making the apparent randomness an illusion of our ignorance, rather than a fundamental feature of nature. For decades, the physics community largely ignored Einstein's objection. Quantum mechanics worked. It made predictions. Those predictions were confirmed. The equations produced results that led to transistors, lasers, and eventually the computer or phone you are using right now. Who cared about philosophical debates when the practical applications were so powerful? But Einstein cared. He never stopped caring. And he kept pushing on this question until his death. If you are still watching, you have already demonstrated something important. You are not satisfied with surface explanations. You want to understand what is actually going on. And what comes next is why this matters so much. Because what happened after Einstein died could have changed how every human being understands reality. In 1964, 9 years after Einstein passed away, an Irish physicist named John Bell did something remarkable. He took Einstein's EPR argument and transformed it from a philosophical puzzle into an experimental test. Bell constructed a mathematical inequality, now known as Bell's inequality, that could determine whether Einstein was right. If hidden variables exist, if reality has definite properties independent of measurement, then Bell's inequality should hold true in experiments. If quantum mechanics is complete, as Bohr claimed, if reality genuinely does not exist until observed, then Bell's inequality should be violated. This was extraordinary. For the first time, scientists had a way to experimentally test who was correct: Einstein or Bohr, realism or Copenhagen, hidden variables or fundamental randomness. And when scientists finally ran these experiments, starting in the 1970s with John Clauser and continuing through the 1980s with Alain Aspect and beyond, the results were devastating. Bell's inequality was violated. Again and again and again, every experiment, no matter how carefully designed, no matter what loopholes were closed, showed the same result. Einstein appeared to be wrong. But before you conclude that Einstein was simply a stubborn old physicist who could not keep up with the times, you need to understand what being wrong actually means in this context, because this is the part that changes everything. And this is why the Nobel Prize Committee used such extraordinary language in 2022. The experiments proved there are no hidden variables of the type Einstein imagined. There is no deeper level of reality, where particles have definite properties before measurement. The randomness of quantum mechanics is not our ignorance. It is fundamental to nature, God. If you want to use Einstein's metaphor, really does play dice with the universe. But here is the revelation that should keep you awake at night. If Einstein was wrong about hidden variables, then he was accidentally right about something far more disturbing. The spooky action at a distance that Einstein found so objectionable, that he used as an argument against quantum mechanics, turned out to be completely real. Entangled particles genuinely do affect each other instantaneously. Not near the speed of light, not very quickly, instantaneously, across any distance. When you measure one entangled particle, its partner responds immediately, whether it is across the room or across the universe. In October 2022, the Nobel Prize in Physics was awarded to Alain Aspect, John Clauser, and Anton Zeilinger. These three scientists spent decades performing increasingly sophisticated experiments on quantum entanglement, and the Nobel Committee did not use cautious academic language. They said explicitly that this work overthrows reality as we know it. Read that again. The most prestigious award in science, acknowledging that our fundamental understanding of reality is wrong. This is not fringe science published in obscure journals. This is not speculation or theory. This is experimentally proven fact, recognized at the highest level of scientific achievement, and the implications go far deeper than most people realize. If entangled particles can affect each other instantly, regardless of distance, then our basic understanding of space is incomplete. Objects are not separate things interacting through forces that travel at limited speeds. At the quantum level, the universe is non-local. Everything is connected in ways that defy our classical intuitions about how reality should work. Einstein saw this coming. He saw it in the 1920s and spent 30 years trying to escape it. In a letter to Max Born dated March 3, 1947, Einstein wrote something haunting. He said he cannot seriously believe in quantum theory because it cannot be reconciled with the idea that physics should represent a reality in time and space, free from spooky actions at a distance. Einstein was not rejecting experimental evidence. He was rejecting the philosophical implications. He was saying that if quantum mechanics is complete, then reality is not what any sane person would expect. And now we know those implications are real. The experiments confirm what Einstein feared, but it gets even stranger. In 1998, researchers at the Weizmann Institute of Science in Israel conducted an experiment that would have troubled Einstein profoundly. They demonstrated that the act of observation itself affects reality, not metaphorically, not philosophically, literally and measurably. They set up a double-slit experiment and varied the amount of observation. What they found was remarkable. The more you watch a quantum system, the more you affect its behavior. Increasing observation caused electrons to behave more like particles. Reducing observation allowed them to behave more like waves. The observer is not passive. The observer changes reality. This is called the quantum Zeno effect, and it suggests something deeply unsettling about the relationship between consciousness and physical reality. Now, I understand the skepticism that might be arising. This sounds like mysticism dressed as science. It sounds like New Age pseudoscience using quantum language to justify magical thinking. Einstein himself would have strongly objected to such interpretations. But the experiments do not lie, and recent research has pushed even further. In August 2024, researchers at TU Wien in Austria performed new measurements of what is called the Leggett-Gaage inequality. This is a test specifically designed to see if macroscopic objects, things big enough to see and touch, behave according to classical rules or quantum rules. Their results were unambiguous. No classical macroscopic theory can truly describe reality. The quantum weirdness is not confined to the subatomic world. It affects everything. And in December 2025, Chinese physicists from the University of Science and Technology of China published results that conclusively settle the theoretical disagreement between Einstein and Bohr. Using a loophole-free test of Hardy's paradox, they confirmed that the strange behavior of quantum particles is not due to experimental limitations or measurement errors. It is a core feature of reality itself. Einstein lost the debate, but losing revealed something he never wanted to discover. Reality is far stranger than he imagined. Far stranger than you imagine, far stranger than any human intuition prepared us for. If you have stayed with me this long, you are part of a small group who actually wants to understand. Most people click away when things get uncomfortable. Most people prefer comfortable illusions to challenging truths. You are different. You want to know what is actually real, even when what is real defies common sense. So, what does this mean for your life? Why should you care about debates between physicists who argued decades ago about particles you will never see? Because this affects everything you believe about existence itself. If reality does not have definite properties until observed, then the solid world around you is not as solid as it appears. The desk in front of you, the walls around you, even your own body. These things exist in a state that is fundamentally different from what you have always assumed. If the universe is non-local, if entangled particles can affect each other instantaneously across any distance, then the separation you feel between yourself and the world is not as absolute as it seems. At the deepest level, the universe is interconnected in ways that transcend space. If observation affects reality, then you are not a passive witness to a pre-existing world. You are a participant. What you pay attention to, how you engage with reality, matters in ways that science is only beginning to understand. Einstein actually told us something profound about time as well, and this connects to everything we have discussed. In 1955, just weeks before he died, Einstein's lifelong friend Michel Besso passed away. Einstein wrote a letter to Besso's family that contains one of the most remarkable statements any scientist has ever made. He said that Besso had departed from this strange world a little ahead of him. That means nothing. For people like us who believe in physics, the distinction between past, present, and future is only a stubbornly persistent illusion. Read those words again, Einstein, the greatest physicist of the 20th century, telling a grieving family that the distinction between past, present, and future is an illusion. He was not offering empty comfort. He was stating what his physics implied. According to relativity, space-time is a four-dimensional block. Past, present, and future all exist. There is no special now flowing through time. The universe simply is. All moments exist simultaneously. What you experience as the passage of time is a feature of consciousness, not a feature of reality. Combined with everything we have discussed about quantum mechanics, a picture emerges that is radically different from everyday experience. Reality does not exist independently of observation. Time is an illusion. Space is non-locally interconnected. and the boundary between you and the universe is far more fluid than you ever imagined. If you have made it this far, you understand why this information does not appear in mainstream education or casual conversation. Not because there is a conspiracy to hide it, but because the implications are so destabilizing that most people simply cannot integrate them into their worldview. It is easier to ignore, easier to dismiss as too abstract or too philosophical, easier to go back to treating reality as solid, separate, and straightforward. But the physics is settled. The experiments are replicated, the Nobel Prizes are awarded, and what they prove changes everything. You just encountered information that most people will never truly absorb. For decades, this was confined to physics journals and specialist conferences. The general public was never given a clear explanation of what quantum mechanics actually implies about reality. Now, you know. When you support this channel through Super Thanks, you are not just paying for a video. You are affirming that understanding reality matters, that truth is worth pursuing. Even when it challenges comfortable assumptions, you are part of a community that refuses to accept the simplified version of physics that gets taught in schools. We want the real story. The story Einstein fought over until his final breath. The story that won the Nobel Prize for overthrowing reality as we know it. Your support makes these deep explorations possible. So, here is what Einstein ultimately revealed. Even through his resistance, reality is not a fixed stage on which events unfold. The universe is participatory. Observation is not passive reception of information. It shapes what becomes real. This does not mean you create reality through wishing. That is a misunderstanding. But it does mean the relationship between consciousness and physical reality is far deeper than materialism admits. Entanglement is real. Spooky action at a distance is real. Einstein used it as an argument against quantum mechanics. Thinking such absurdity proved the theory incomplete. Instead, experiments proved entanglement is a genuine feature of reality. The universe is non-local. Everything is connected. Time as you experience it is not fundamental. The flow from past to future is one, as Einstein said, a stubbornly persistent illusion. All moments exist. What this means for free will, causation, and identity remains one of the deepest philosophical questions of our age. And the observer effect is experimentally verified. How you engage with reality influences what reality becomes, not through magic or intention alone, but through a precise physical mechanism that has been measured repeatedly. Einstein did not want any of this to be true. He fought against it with every argument he could construct, and his fight pushed physics to prove these things with absolute experimental certainty. The greatest irony of Einstein's career is this: by resisting quantum mechanics so vigorously, by demanding evidence and constructing thought experiments like EPR, Einstein drove the development of the very experiments that proved him wrong. His stubbornness advanced science. His refusal to accept easy answers forced others to find definitive answers. But in proving Einstein wrong about hidden variables, physics revealed that he was right about the strangeness. Quantum mechanics really does imply bizarre things about reality, things that defy all classical intuition, things that suggest the universe is far more mysterious than any materialist worldview admits. This is what they did not teach you. This is what Einstein discovered and spent 30 years trying to escape. This is what 3 scientists won the Nobel Prize for proving, and this is what you now understand me. The question is not whether this is true. The experiments have settled that debate. The question is what you do with this knowledge. How do you live in a world where reality is participatory, where time is an illusion, where everything is connected, at a level that transcends space? Einstein struggled with this until his death. He never found peace with it, but he kept questioning, kept searching, refused to accept easy explanations, even when they made him uncomfortable. That relentless questioning might be his greatest legacy. You now hold knowledge that most people will never encounter or understand. The solid world they believe in has been experimentally disproven. The separate objects they think exist are interconnected in ways that defy locality. The flowing time they experience is a stubborn illusion, and the act of observation itself shapes what becomes real in ways that science has measured, but philosophy has not yet fully processed. This is the legacy Einstein left us, not just equations, not just theories, but a fundamental question about existence that remains unanswered, even as the experiments pile up. What do you believe? Do you think Einstein was right to resist quantum weirdness for 30 years? Or did his defeat reveal something essential about how the universe actually works? Comment below. Tell me whether you think reality exists independently of observation, or whether Einstein and Bohr's century-old debate exposed something far stranger about existence itself. I read every comment in the first 2 hours, and the conversations here often go deeper than the videos themselves. Reality is not what you think. And after today, you will never see the world the same way again.